Hi everyone, welcome to Vedantu JEE English. I'm Diksha, your chemistry master teacher. So welcome all the JEE 2027 aspirants. I know some of you are also JEE 2026 aspirants who are confused about unit conversions. Okay, so guys, this is going to be a very short lecture of maybe 50 or 60 minutes, or maybe 1 hour, like not more than that. In this, I'm going to talk about very basic things. One is some physical constants that are there in physics, right? Their units, right? And the conversions, like we see that Joule conversion to electron volt, atmospheric conversion to Pascal, then you have torr, you have mm of Hg, all these are the units of pressure. Then ma'am, how to convert nanometer to centimeter to gigameter, all these things that are there. Armstrong, all these things, right, we are going to talk about in today's lecture. Okay, so if you all are ready for this, then let me know in the chat box and be ready with the session and give him the uh, I would say green hearts or fire emojis, right? Whatever you like, green hearts, fire emojis, whatever is your favorite. Give it, smash the chat box with green hearts and fire emojis in the chat box, right? Okay, very, very good evening. And guys, very important announcement for all the JEE 2027 aspirants, right? That is, guys, you know our result, our shining stars here. AIR 15, Karnataka state rank 1, right, is from Vedantu, right? So that is a very amazing thing. And if you also want to be in this category, if you also want to be the shining star, right, then guys, we have a very important offer for you. That is IV SAT scholarship program. That is instant Vedantu scholarship aptitude test, right? Here, according, like, what are the marks that you will get in this scholarship test, you will be provided with the scholarship. Up to 90% scholarship you can get here. And students, in this, we are also giving the droppers or the repeaters, right? We are also providing them with the guaranteed rank improvement or 100% fees refund. That means you will definitely see the improvement in your rank, right? Otherwise, we can take all your fees back, right? Okay. Then if you're like, ma'am, I need more detail on this, then guys, you can talk to our counselors. Like, you can just call here. You can visit our center in Bengaluru, JP Nagar. If you're like, ma'am, but I am not in Bengaluru, then what to do? You can see all over India. These are our offline centers. You can visit any nearby offline center. Talk to the counselor, talk to the teachers. You can just say that I'm from Vedantu JEE English. Definitely the help will be provided to you, right? And the right guidance, mentorship will be provided to you, right? So it's totally your choice what path you want to follow. You want to put down your efforts in the right direction or to just waste your another year, right? That's totally your choice, right? I can just advise you one thing, that please make a wise choice, right? Don't make choice just like that. Okay, it's not a hit and trial, it's your life. Every single moment is very, very crucial for you, very, very important for you. And for all the JEE 2027 aspirants, no, today one video is coming, that is roadmap of JEE, right? There I have told you everything, right, in these 2 years, how you're going to cover your entire chemistry roadmap is there, right? Okay, so now let's just talk about what we are going to do today. Right, students? Okay, everybody, what we are going to do today. First is we will talk about simple unit conversion, then temperature unit, pressure unit, volume unit, gas constant, energy. In the end, we will talk about some important physical constants, right? So one by one, we are going to talk about it. Let's start with the international system of units. That is your SI units, right? So can anybody tell me in the chat box what is the, yes, what is the SI unit? What entire portion means what? Entire portion, are you asking about roadmap or you're asking about IV SAT program? What you're asking? Okay, let's see this. What are the basic units? Basic units are mass, that is in kilogram. Basic unit is time, that is in seconds. Basic unit is mass, you can say, time, you can say, what else? Gram, seconds, yes, length, right? length, that is in meter. So these are the SI units. Derived units are like you have velocity. You have velocity. Now velocity is meter per second. It is derived from the basic units like you have meter and you have seconds. Like you have density, right? Density is equals to mass by volume, right? Mass is in grams, volume is in liter, milliliter, or that is also called decimeter cube. That is in, it is expressed in decimeter or centimeter also, that we will talk about in volume units, right? So all these units are your derived units. Two kinds of units we have, right? So let's get into detail of this. If you talk about the basic units, what are the basic units that you have? First basic unit is length. That is given in meters. That is the SI unit of length, right? Mass is in kilogram. That is the SI unit of mass, right? Usually students confuse this, that mass SI unit is gram. No, it's kilograms. In chemistry, you will see mostly grams because we take very small quantities while doing some reaction. Okay. Time is in seconds. Electric current, that is in amperes, right? That is represented by A. Thermodynamic temperature, the standard, the SI unit, right, of temperature is Kelvin. That's why in most of the formulas of chemistry, you will use Kelvin here. Most of the formulas, when temperature is given in degrees Celsius, you convert it into Kelvin, right? Usually students who don't have enough knowledge about this, especially in the starting of class 11, they tend to confuse that why I have to convert degrees Celsius into Kelvin, because Kelvin is the SI unit here, right? Okay, so that I'll tell you that how to convert degrees Celsius to Kelvin, that don't worry about that thing. Next is amount of substance. Whenever we talk about, we are talking about the amount of substance, right? That if it is not mentioned, you will think that it is given in moles, right? Always amount of substance is given in moles. That is a mole concept you have studied in some basic concepts of chemistry. We will study about this mole, right? Then we have luminous intensity. This is very, you will not use this last one in your entire chemistry, but still, okay, for JEE advanced, it may be somewhere, but till JEE means maybe it's just one portion of some question may be there in JEE advanced, but otherwise, no. You can just get to know that, okay, intensity, the SI unit is candela, that is represented by this CD. So all these are your basic units, right? Clear on this? Shall I start with the derived units, guys? What is the derived unit? Like you have unit of velocity, that is meter per second. Unit of acceleration, that is meter per second square. All these are your derived units that are derived from the basic unit, maybe multiplication, division of the basic units, right? Also fundamental units, right ma'am? Yes, Hema, they are also called fundamental units. Basic units, fundamental units, right? And these are your derived units, right? Now, main things start from here and the confusing part starts from here, right? Firstly, I'll tell you what are the important, it's not like you just have to do what is important, okay? I'm giving you the full page, but you have to do everything. It's not like you just have to do the important part here, right? But still, I'll tell you what is important, what mostly I have seen in chemistry numericals. One is pico, nano is highly used, micro, milli, centi is highly used, right? Then you have deca, deci is highly used, kilo, mega. Then these are not that much used. Okay, in chemistry, these are not used. Mostly these things are used. Okay, that I have mentioned, that I have ticked, these are mostly used. You will also use most of the things, like will be either they will give you nanometer, picometer, micrometer, millimeter, centimeter. So I'll just write the corresponding, like for these, what is the symbol? Pico is represented by P. This is represented by N. This is micro is represented by mu. This is represented by M, small m. This is represented by C, centi. This is represented by D. This representation is given here. Kya? Oh, representation is given here. I'm so sorry. Right? Representation is given here, guys. Right? Already given. Pico, nano, mu is represented. Why I mentioned it here? Micro is represented by mu, right? Then milli, then centi. Why I'm giving you this representation also here? Because sometimes they will give you something in mu, let's say mu second, mu kilogram, mu grams, right? Mu, what else? Meter, right? These kind of things, if they give you should know what is mu, right? Okay. Now, beta, remember one thing. All these, okay, teachers will give you different methods to understand this thing, right? What's my method? I'll tell you that. If you relate with that method, if that method is making it easy for you, good. If that method is making it difficult for you, you can leave that. You can do your own method, right? So I'll tell you that what I do, how I have learned it when I was in your, like when I was of your age, because I used to get very confused in this, right? I used to be very good in numericals, but I used to get confused here, right? So that's why I took up this lecture for you, because I know the pain point, right? Because this also have been my pain point, how I clarified it to myself. Simple thing is, if something is small and you're converting into something big, you will always divide it. Something is big, you're converting it into something small, you will always multiply it. It's the opposite of what we think is going to happen. Okay, if something is small, you want to convert it into big, you think that it should be multiplied, but in reality you are going to divide it, right? But when something is big and you're going to convert it into something small, then you're going to multiply it, right? Okay, now I'll give you one example of this, what I want to tell you. Let's say 1 kilogram is equals to 1000 gram. This we all know. We have seen this, right? This all of you know, right? This all of you know. 1 kilogram, that's a simple thing. I'm not even picking up these units right now, right? 1 kilogram is equals to 1000 grams. Now understand one thing. If I say that 1 kilogram is 1000 grams, just remember 10 raised to power 3. Just remember 3. That 3 zeros are there, right? 3 zeros we have here, right? It means it is relation by 10 raised to power 3. Okay, because it is easy to convert it like this, but when it comes to pico, nano, then it becomes difficult, right? Just remember 10 raised to power 3, right? Kilo means, just remember that kilo means 10 raised to power 3. Okay, now instead of remembering this, you just remember this thing, that kilo means 10 raised to power 3. Now, let's say I want to convert gram to kilogram. That means what I am doing, I am converting small to bigger value, small to bigger value, small to bigger value, right? If you are converting, then you will always divide, right? So that means if I have 10 grams, then I will divide it by 10 raised to power 3. This will be your kilogram, that is 10 raised to power minus 2 kilogram. Okay, this is the simplest part that we have done. Now, let's do difficult things here, right? Remember that meter, like I told you, na, mole is mummy, right? Mole is your mummy. So you have to create a mummy here, right? Who is your mummy here? Tell me. Who is the one you will always go to when you are like totally upset in life? The one person that you will always, your go-to person, right? Who is the go-to person? Here the go-to person is simple with no nano, no nothing, right? No nano, no meter, simple. If I talk about, there is kilometer, nanometer, or there is picometer. No, I am talking about simple thing that is nothing, right? If I talk about meter, let's talk about length. Okay, I'm talking about in the units of length. Okay, let's pick one thing. Let's talk about length here, right? You're talking about in the units of length. Or do you want to talk about in the units of gram? Totally your choice. Tell me, like, in which units you want me to talk about. You want me to talk about grams, or you want me to talk about meters, right? Which thing? Because these two things only you will use maximum in your chemistry, right? Everybody, what you want me to talk about, grams or meter? This gram or meter is your base quantity. Compared always whenever 2-unit conversion are given to you, you will always convert it to your base quantity. Your base quantity is grams, meter. These are your base quantities, right? Is this for class 11? Yes, beta, this is for class 11 and this is for class 12 as well, right? If you're in class 12, you have no idea about unit conversion. This is for every student whose unit conversions are weak. Whether you are a dropper, you are in class 11, you are in class 12, doesn't matter. But for class 11, if you are blank right now, is this for me or not? Definitely this is for you, right? Okay, right? Now, beta, tell me, gram or meter? Should I take it by myself only? So I'll talk about grams. Okay, grams is your base quantity, right? Now the quantities that are like smaller than this: yactogram, zeptogram. Zepto is also an app, no? Attogram, femtogram, pico, nano, micro, milli, centi. All these are small, right? This you can remember, right? But these are most important. Pico 10 raised power minus 12. Just remember, pico means 12. Pico means 12. Nano means 9. Micro means 6. Milli means 3. Centi means 2. Right? That should be on your tips. Everybody, pico means 12. Now all these are smaller. Pico means 12. Then you have nano means 9. Then you have angstrom, right? Angstrom means, angstrom we will discuss later, right? This is 9. Micro means 6. Milli means 3. Centi means 2, right? And if you talk about the bigger values, right, then kilograms, bigger values are, you have deci. Deci is also small, okay? Deci is also small. Deci means 1. 10 raised, this is, we talk about 1. 10 raised per 1, right? Now, if you talk about bigger values, from here we'll start with the bigger values. Deca means 10. Deci means 10. Deca also means 10. Deci is a smaller value than the base value. Deca is a bigger value than the base value, right? Now, if you talk about hecto, that means 2. Kilo means 3. Mega means 6. Giga means 9. Okay. Tera, terabyte, petabyte, I think you must have heard about that. Tera means 12, peta means 15, exa means 18, zeta means 21, iota means 24. That you can remember, but usually that are not these things, they don't ask you. Usually they ask you till here, but I would advise you to remember everything. What if they ask you any of this thing, right? Okay. Now, let's do the conversion. I know till now you're completely blank that, ma'am, what exactly you are telling us. Okay? Now, I'll do the conversions with you. Then you will be able to understand how to apply what I'm telling you. Right? Let's see this. Let's apply this. Okay? All these are including deci. If I write deci here only, deci, that is 10 raised per minus 1. Right, that is represented by this D, that is smaller than smaller values. When you are declining, the curve is declining, and all these are the bigger values. All these are the bigger values than the base value. Okay, you should just remember that what are the smaller values, what are the bigger values, and what is 10 raised to power value over there, right? Now, let's see the conversions, okay? First conversion that you have here is, first conversion, guys, that you have here is, that is 2 mg, capital Mg to gram, right? This is what the conversion is given to you. Now, capital M representing what? Capital M is representing mega. That is 10 raised to power 6. Mega means 6. Mu also means, see, micro also means 6. Mega also means 6. Right? I'll tell you how to convert it to both. Right? Micro also means 6. Mega also means 6. The only difference is when you're converting a meter to micrometer or to megameter, the difference is that in meter to micrometer, meter is this, micro is smaller than that. That means you will multiply this by 10 raised power 6. So here you will multiply by 10 raised power 6, right? Here you will multiply by 10 raised power 6. But let's say if you have megameter, this is meter, you're converting it to something bigger. When you convert it to something bigger, that means it will be divided, right? So it will be divided means it will be multiplied by 10 raised power minus 6. Okay, students, got it what I exactly want to tell you, right? I'll just write it on a different page so that you understand it well, right? I'll just take a page here, right? See, students, simple thing is, let's say you have, before doing those things, you should know this, right? Let's say you have meter to micrometer, right? This is 3 meter to micrometer. We don't know what is that. This is 3 meter to megameter, right? That you have to convert. Simple thing is, this is meter. When you go to mega, it is increasing. When you go to micro, it is decreasing. When you go from smaller to bigger, you divide. When you go to bigger to smaller, you multiply. Okay. So here what we will do, this is multiplied by 10 raised to power 6. This will be 3 into 10 raised to power 6. This is multiplied by this thing, right? Okay. And what about megameter? This will be 3 into 10 raised to power minus 6. Got it, everybody? Is that thing clear to everybody or not? Is that thing clear to everybody what I did here? Why you have to multiply, why you have to divide here, right? Okay. Now, let us talk about something else, right? Let's talk about pico and tera here. This is tera is also 12. Pico is also 12, right? Pico is also 12. Okay. So you need to convert 20 gram to picogram. Usually we see mu gram and this is na. So let's do it in meter only. Let's say 20 meter to picometer you have to convert and to tera meter you have to convert. Right? Okay. Let's see this here, how you're going to do this. So this is your meter. When you go to tera, it is increment. When you go to pico, it is decrement, right? Whenever you're going to a bigger value, you always divide. Whenever you're going to a smaller value, you always multiply. Multiply with what is the zeros here. So this will be multiplied by 20 into 10 raised to power 12 here, right? That is your picometer, right? Okay. This will be your 20 into 10 raised to power minus 12 tera meter. Tell me, beta, if this thing is clear to everybody or not, right? For micro, it is 10 raised to power minus 6. Micro, it is 10. No, the reverse is not right. I'll tell you how. See, if I am putting the value of mu, the value of mu is what? The value of mu is given to be, if you want to verify this, the value of mu is given to be 10 raised to power 6. Okay. So here, simple is, if you multiply, this is 3 into 10 raised to power 6 multiplied by 10 raised to power minus 6 meter. So that will be 3 meter, na? Right? 10 raised to power 6 multiplied by this. If you put the value of capital M here, that is given to be 10 raised to power 6, that you will get 3 into 10 raised to power minus 6 multiplied by 10 raised to power 6 meter, that will come out to be 3 meter. Right? Okay? Okay. Got it? How you're going to do it? Right? So that's why this gets confusing. That's why I'm written it this way, right? So that you get a like clear view of that, right? Okay, everybody. Uh, hello, 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 hello. Students, am I audible? Students, am I audible? Hello, hello, hello. Guys, am I audible to you, all of you or not? I am audible, right? Yes. Okay. I think there was some lag in between. Okay. So that is clear to everybody now. Why? Because this gets confusing. Usually students what they think what I have seen like people doing. Okay, this is pico. So let's multiply it by 10 raised to power minus 12. That's why this lecture I am taking. Just remember that. Just remember which is bigger, which is smaller. If you're going towards bigger value, you need to divide it by that number. If you're going towards smaller value, you need to multiply, right? So here we have mega is the bigger value, so we will divide it by 10 raised to power 6. This is the smaller value, mu is the smaller value, so we'll divide it by 10 raised to power 6, right? This also correspond to 10 raised to power 6, this also correspond to 10 raised to power 6. This also correspond to 10 raised to power 12, this also correspond to 10 raised to power 12. That thing is clear to everybody or not, right? Because now things are going to get more complicated for you, right? Okay, let's see the next one here, right? Micro to mega, we will do that, don't worry, right? Now let's do this thing. Okay, let's do this thing. Let's do this thing. I'll just put it here, right? 1 megagram to gram, 1 or 2 megagram to gram. Better tell me one thing. Megagram, gram is a base unit, okay? Base unit. There is no micro, milli, giga, teta, anything is not there. So it's a base unit. So let's do 1 for 1. If you talk about 1 megagram, right? If you convert it into gram, you are decreasing the value, decreasing the unit. When you're going towards a less unit here, lesser unit, right? Then what you will do? You will divide it. Mega definitely means 10 raised to power 6. Mega means 10 raised to power 6. That means you will divide it with 10 raised to power 6. Right? Because you're moving from this to this. So you have to divide. Not divide, you're moving from bigger to smaller, you will multiply. No. When you're moving from bigger to smaller, you will multiply. Okay, bigger to smaller is when you will multiply. You can also draw it like this. That will be better for you. Right? When you're going from bigger to smaller, you will always multiply. Whenever it is like this, you will always multiply. If it is like this, you will always divide, right? So multiplication is there, and mega means 10 raised to power 6. So we have to multiply this with this. So 2 megagram is equals to 2 into 10 raised to power 6 grams. Okay, 2 megagram is equals to 2 raised to 10 raised to power 6 grams, right? Now let's do the next one that is given to you. That is given to you as 20 centimeter to millimeter. Okay, 20 centimeter to millimeter. Who will solve this? 20 centimeter to millimeter. Okay, you have 20 centimeter. Always convert it into base meter. Base. Better tell me what is the base unit of meter. Base unit of meter is meter only, right? So firstly, we will convert centimeter to meter. That is a bigger unit. Whenever you're converting something to a bigger unit, right? Just remember BD. And you have, when smaller is there, then you have to do this. Bigger means you have to divide, smaller means you have to multiply, right? So now I'll just write it somewhere here. BD smaller है ना? Okay, chalo. You just have to remember this, right? Now, if something is going from smaller to bigger, right? In this case, you will have to multiply this, right? Then you multiply, right? Multiply. Now, when you are multiplying this, right? Tell me what is the like pointer here? 10 raised power 2, right? Centi means 10 raised power 2. So you'll have to multiply it with 10 raised power 2. So I'll just convert it into 20 into 10 raised power 2. That will be in meters. Now meters to millimeter. But now you have meter. Meter is getting converted to millimeter, right? Meter is getting converted to millimeter. Now tell me, meter to smaller. Smaller means you have to multiply this, right? You have to multiply this, right? So meter to smaller value, that is you have to, I don't know why I am confused. I'm so sorry, yaar. I think I am doing wrong. I'm sorry. You have centimeter to meter. In centimeter to meter, when you're going from smaller to bigger, then you have to divide it. So it will be divided by 10 raised power 2. So it will be 20 into 10 raised power minus 2 meter, right? Now, this meter will be converted to millimeter. Now you are decreasing the value. So that means you have to multiply it, right? And milli means 10 raised to power 3. So that means you have to multiply it with 10 raised to power 3. So answer will be 20 into 10 raised to power minus 2 multiplied by 10 raised to power 3 millimeter. It will correspond to, this is 20 into 10 raised to power 1, and that will be 200. 3, 4, 4 minus 2 is 2. So it is going to be this millimeter. Okay. Heights reverse. Okay. Now let's do the third one. That is 1 meter. This is so very simple. 1 meter is equals to 100 centimeter. We don't even need to solve it. Right. Now let's do this. Let's convert these units here. Let's convert these units. 10 raised to power 3 nanometer to femtometer. Right. Let's convert these here. 10 raised to power 3 nanometer. 10 raised to power 3 nanometer. This is the last 3 conversions that I am doing here. If you have any problem in this, you can ask me here only. 10 raised to power 3 nanometer to femtometer. Dash femtometer. The base unit of length is meter. Okay, so first you will have to convert this into meter. Right? Let's convert this into meter. But now tell me, nanometer is smaller or meter is smaller? Nanometer is smaller, right? Nanometer is smaller. So nanometer to, if you convert this into meter, we are going to the bigger unit. Bigger unit means we have to divide it, right? We have to divide it. And nano means, nano, have you heard about that car that was there when I was young? It was very famous, right? 10 raised to power 9. Nano is 10 raised to power 9. So that means you have to divide it with 10 raised to power 9. So it is 10 raised to power 3 multiplied by 10 raised to power minus 9. Because on division it will be minus 9. This is your meter. Right? This is your meter. Got it? Now beta, what else you have to do here? Right? Now, let's convert it into femtometer. You know, why I'm telling you this way of answering, the reason being, when you just cram this way, when you just cram this way, if you cram that this nano is 10 raised to power minus 9, sometimes, see, it is valid if you convert 1 nanometer to meter, just directly put this value that is given here, you will get your answer. But when there is a thing called meter is converted to nanometer is where students get confused. That's why I'm telling you this way, so that you don't get confused in the exam. Okay, this is to eliminate all the confusions in the exam that you have, right? So this is 10 raised to power 9, right? By practice, this will be like, you can solve this in seconds, right? So now what you have, meter to femtometer, right? Now femtometer is less or more. Femtometer, beta. Femtometer is here you have, right? This is femtometer, 10 raised to power minus 15, right? So let's take this here. Femtometer, usually it is not asked, right? But still, I'm just telling you this for the conversion. Again, you're going to a lower value. When you're going to a lower value, a smaller value, you will multiply it, right? Femto means 10 raised to power 15. You have to multiply it with the 10 raised to power 3 multiplied by 10 raised to power minus 9 multiplied by 10 raised to power 15. 15, 16, 17, 18. 18 minus 9 will be 10 raised to power 9 femtometer. Okay, right? Okay. Ma'am, why should we centimeter to meter then to millimeter? This I am telling you because some students, they get confused. They don't know how to convert millimeter to centimeter directly, how to convert nanometer to angstrom directly, right? So when there is this confusion, that follow this path. Firstly, convert everything to the base value. Then your question can never go wrong, right? Okay. Now let's do this thing here. Next is you have gigagram to gram, right? Now what is giga, everybody? Giga, as you can see here, find out, locate giga. Giga is comparable to nano, right? Nano is when you decrease it, it will be nano. When you increase it, it will be giga, right? So you can just write it here, right? 1 gigagram to gram. In this case, now when you have something given here and you're converting it into a base unit, then you don't even have to think, right? Just put the value of giga, that is 10 raised to power 9, right? If you're not able to understand this, simple thing is gigagram is bigger, gram is a smaller value. So it is a smaller value, that means you have to multiply it. And giga means 10 raised to power 9. Okay, so it will be 10 raised to power 9 gram. Okay. Okay. Let's do the next one and the last one here. Let's see who is going to answer this. 0.002 nanometer to picometer. 0.002 nanometer to picometer. Right? Okay, let's see how many of you are able to answer this question. 0.002 nanometer to picometer. Okay, let's see that, everybody. Let's see that. Okay, so simple thing is, firstly convert it into nanometer to meter, right? Then meter to picometer. Achha, now I am telling you how to not to convert it into meter, directly do this, okay? See this. Nanometer to meter, meter to picometer, okay? In this case, when you're increasing it, right, you have to divide it, right? And here you have to multiply. Here you have to divide it with 10 raised to power 9. So it will be multiplied by 10 raised to power minus 9. Here you have to multiply with pico. Pico means 10 raised to power 12. So it will be multiplied by 10 raised to power 12. So when you multiply something with 10 raised to power minus 9 and 10 raised to power 12, it will become 10 raised to power 3. So can I just directly multiply this with 10 raised to power 3? That means 0.002 multiplied by 10 raised to power 3. This will be 1, 2, 3. It will cancel out and it will give you 2 picometer. Okay. Yes, everybody. Clear? Is that clear to everybody? Either you can firstly convert it to meter by multiplying with 10 raised to power minus 9, then multiplying with 10 raised to power 12. Or you can just multiply these two things together. You will get 10 raised to power 3. You just multiply it there. Right? Okay. Clear, everyone? So let's move to the next thing. If there is any problem in the conversion of nanometer, millimeter, megameter, or if you want me to do one more question, then let me know in the chat box. And one thing is there, I'll give you one homework in the end, I'll give you that. Okay? Yes? Okay? If everything is clear till now, then spam yes in the chat box so that we can start with the next thing here. Okay, students? Right, everybody? Let me ask you here, You can just answer me in the poll also if you are lazy to type. Huh? Okay, let's see. Yes or no? Till here, right? 97 students are saying that yes, we are about to like the video, but till now 47 likes only we have. So many liars in the class. Huh? Okay. Now the next topic, students, we have is temperature. Okay, temperature and its units. Okay, let's start with temperature and its units. Right, students, let's start with temperature and its units. So temperature has basically three units: degree Celsius, Fahrenheit and Kelvin. And Fahrenheit, very rare. In JEE Advanced, maybe you will see. In JEE Mains also, very, very rare chances that they will give you in Fahrenheit. But the most common conversion is from degree to Kelvin. Right? This is like most common thing that is used in chemistry. Right? Fahrenheit is not used that much, but you should know this. Right? What if they give you the question in Fahrenheit and you have to convert it into Kelvin or degree Celsius? So for that you should know. Right? Now let's talk about the first conversion, that is Kelvin to degree Celsius. So if let's say 0 degrees Celsius is equal to 273.15 Kelvin. That means whenever you have any degree Celsius, you add 273, approximately you can add 273 also. You will get the temperature in Kelvin. Okay. Now everybody tell me the answer. What is 25 degrees Celsius? What is 30 degrees Celsius in Kelvin? What is 27 degrees Celsius in Kelvin? Okay. Everyone in the chat box, what is 25 degrees Celsius? That is 273 plus 25, that is 298.15. You can put here 0.15 if you want to put 15 plus, usually we take 273 also, but you can add also 0.15, totally your choice, but approximately that will also work. 298.15 Kelvin. What about 30? Very good, 298.15. What about this 30 degrees Celsius? 275.15 added with 30 degree, that is going to, this you have seen in your earlier classes also, in 9th or 10th class it was there, right? That is going to be at 30, 80, 90, 100. So this will be 305 plus 15 Kelvin, right? Okay. Yes, everybody. Vector hai, vector you are talking about in chemistry, vectors and all, that is, you can study that in physics. Huh? Yes. Okay, let's talk about 27 degrees Celsius. Who will give me the answer? 295, wait a minute, 70, 80, 90, 70, 80, 90, 5, no? No, it will be 305.15. Here I don't know why I'm doing these silly mistakes. 273. Then also it will be 303, no? 303, no? It will be 0.15, 27 plus 3, that is going to be 30, right? 303.15. 300, okay. Sharth has given the next one, that is 300.15. So directly you can write here 273.15 plus 27, right? That is going to give you 27 here. That is going to be 300.15 Kelvin here, right? So these are the most common conversion that you will see. That should be in your head, that 0 degree corresponds to, okay. Tell me, what is 100 degrees Celsius? 100 degrees Celsius correspond to which? 273.15 plus 100, that will correspond to 373.15 Kelvin. These are the most common temperatures that you will see, especially 25 degrees Celsius, 27 degrees Celsius, 100 degrees Celsius. These are some of the very common temperatures that you will see in the upcoming numericals of physical chemistry, right? Okay. Now, let's talk about, this is a very rare like formula that is used, but still you should know this, right? If you actually want to have a good hold in physical chemistry, this formula you should know. Degree Celsius conversion to Fahrenheit, right? Or Fahrenheit conversion to degree Celsius, right? That you can do with the help of this relation here. Let me just write it here. This is your degree Celsius, right? This is your Celsius and this is Fahrenheit, okay? This you should definitely know, right? Okay, students. Now, that was about temperature. Let's see, let's convert this. Most of the conversions we have done. Let's see who is going to answer this. First, second, and third. Okay? First, second, and third. First, all of you have already answered. First is going to be 373.15 Kelvin, right? What about second? What about second? Everyone, what about second? 40. Add 40 into it. 273.15 plus 40 is going to be 0.15 here. 3 is here. 7 plus 4 is 11. 313.15. 313.15 Kelvin. Let's see the last one, that is 50 Kelvin to degree Fahrenheit. Okay? 50 Kelvin to degree Fahrenheit. Let's see who is going to answer this. Okay. Yes, everybody. Okay. Firstly, Kelvin to degree Celsius. Can you tell me if you have 50 Kelvin? In degree Celsius, firstly you convert. Then you convert that degree Celsius to Fahrenheit. Okay. Yes, everybody. I am waiting for your answers in the chat box. Yes, everybody. So if you want to see the formula, you can see it here, right? Let's see who is able to convert. Okay, let's convert 50 Kelvin to, firstly convert it into degree Celsius, right? So Kelvin is given to be 50. Degree Celsius, we have no idea, plus 273.15. That means degree Celsius will be 50 minus 273.15. Solve this. Degree Celsius, in degree Celsius, that will be in negative beta. Let's solve this. This is going to be 50 minus, I'm just using the calculator here, right? 0.15 minus 223.15 minus 223. Yes, it was easy calculation only. Though, right? Let's convert this into Fahrenheit. Okay. So this will be minus 223.15 multiplied by 9 divided by 5 added 32 will give you the value of Fahrenheit here. Right? Okay, everybody. Let's see who is going to answer this. Don't forget to have the minus over there. Right? Let's see what I am getting. 223.15 multiplied by 9 divided by 5. Okay, that means minus 401.67. I know calculation is weird, right? This you have to add 32 into it. Yes, you will get Fahrenheit will be equals to minus 369.67 Fahrenheit. Okay, that is the value of 50 Kelvin in degree Celsius, in degree Fahrenheit. Okay, so that means you can do any conversion here using these two formulas. Okay, ma'am, 2 is Celsius to Fahrenheit. 2 is Celsius to Fahrenheit. Where it is? This is also Celsius to Fahrenheit. Then let's convert this into Celsius to Fahrenheit. Let's convert this into Celsius to Fahrenheit. Right? Let's convert this. This is coming out to be 50 Kelvin is equals to how much it is coming out to be? Minus 369.67. Minus 369.67 Fahrenheit. Okay. Now Next question that is given to us is this, okay. I'll use this formula only here. That is how much 40 degree you have to convert, right? 40 degree, guys, you have to convert here. 40 degree to Fahrenheit. Degree is given in positive, Fahrenheit will also be in positive, right? If you see this here, 40 is equals to multiplied by 9, because this will multiply, this will be divided by 9, plus of 32 is equals to Fahrenheit. Now beta solve this. 5 into 8, right? You can easily solve this now, bacha. Easily you can solve this. Everybody, I'm waiting for your answers in the chat box. I am waiting for your answers in the chat box, guys. Yes, everybody. Now, so you can easily, this was an easy one, right? What is the answer? Will this be negative? This will not be negative. If you're answering the last one, then yes. Why this will be in minus? No, this will be not in minus 36. Not in minus 36, beta. This will be 72 plus 32. What is going to be? 4, 7, 8, 10. So it is going to be how much Fahrenheit, right? That means, can I say that 40 degrees Celsius is equals to 104 degree Fahrenheit? Like you have our body temperatures when we usually have this in the thermometer, we usually measure this in Fahrenheit. In most of the thermometer, it is in Fahrenheit, right? So if you talk about 40 degree, that will be 104. Acha, tell me one thing, is it relatable to your life? If someone asks you what is, like someone has fever, someone is feverish, we say how much is the fever? We never talk about Fahrenheit, right? So we say 97 Fahrenheit is normal for our body, 97 to 98. If it is gone to 100 Fahrenheit, 102, 104, it's like extreme feverish fever you have, right? It can be dangerous, right? In reality, we are talking about 40 degrees Celsius, right? So right now, if you talk about like nearby the surroundings, the temperature is rising to 40, 45 degrees, right? But our body, like 38 degrees to like this much only it can handle, right? Okay, so that depends, right? Clear, no students, about temperature, right? I think by doing these questions, that would have been more clear to you what is degree Celsius, what is degree Fahrenheit, and what is Kelvin, right? Okay. 98.4 Fahrenheit is normal. Okay. Yes, 98 something is normal. I didn't know the exact temperature, but yes, 98.4. But even if you have 99 or 100, right, that is fever only, right? So body temperature, right, that should be normal, right? Now let's talk about some scientific notation. This also you will see in physical chemistry throughout. This is any number. Let's say I am representing 0.0003. Will you see these kind of options in the exam? You have calculated the answer like this, 0.0003. But answer, it will not be given like this. Answer will be given like this, 3 into 10 raised per minus 4 meter, if this is in meter, right? So that's why I have seen students, they will answer everything, formula they will put correctly, calculation they will do right. Sometimes the formulas, the options are quite matching with each other. It's like 3 into 10 raised per minus 4 meter, 3 into 10 raised per minus 3 meter, 3 into 10 raised per minus 4 millimeter, right? All these options they will give you and you will end up getting confused in the exam, right? So that's why for these kind of things, we should know conversion also. We should know also how to convert it into scientific notation, okay? For that also, giving you just the definition will not work. I have to give you the examples here. Let's see the example, okay? First example is 3, 1, 2, 3, 4, 5, okay? So these are the values that you are getting here. So it will be 3 into 10 raised to power 5, right? If this is in, let's say, meter, this will also be in meters, right? Now let's see, in the question, they are giving you the answer in nanometer. Can you tell me what is the nanometer of this? Students, can you tell me what is the nanometer of this? Can you tell me what is the nanometer? Now, bacha, meter, when it is converted to nanometer, we always, smaller means we have to multiply it. Multiply it with nano means 10 raised to power 9. So that means 3 into 10 raised to power, wait a minute. When you are like this is converting to the smaller value, you'll have to multiply, right? So it will be multiplied with 5 and this is 10 raised to power 9 nanometer. So that will be converted to 3 into 10 raised to power 14 nanometer. And this is where students get confused in the exam, right? Okay, understood? If they ask you the answer, why I'm again focusing about nanometer, picometer, because this usually answers are like that only, right? So if they give you this in picometer, right? So how you convert this into picometer? Let's do the next one in picometer, okay? Same we will not do. They are asking you, this is given in grams, okay? They are asking you to answer this in new grams or milligrams. Let's say they are asking you to answer it in milligrams in the scientific notation, in the simpler value, right? So first I'll convert this into a simpler version, okay? I will not answer it like 0.000. I'll have to convert it into simpler version. This means that you have how many, if you see, one simple thing is if you have 0.001, those who are weak in math, for them I am telling you, I don't think that JEE aspirants will be weak in math, but still, who are weak, I'll telling you for that. This is 1, 2, right? This has no value. If you have any solid digit, before that, no zero has value. After decimal, only zeros have value, right? So this is, you have, when you erase this point here, this will be 1, 2, 3. It will be 3 values here. That means, let's say, if you have 0.721, that means this will be 721 multiplied by 10 raised to power 3 units after this minus 3. Let's see, you have 0.0002. 1, 2, 3, 4. 4 units after this, that means it will be multiplied by 2 will be multiplied by 10 raised to power minus 4. That means it will be 2 divided by 1, 2, 3, 4. That's how you got 0.0002. Okay? Understood everybody? Understood everybody that simple concept here, right? Okay, now let's see this. Okay, this is 0.00832, right? 0.00832 means 1, 2, 3, 4, 5. That means it will be 10 raised to power minus 5. So you can write 832 because before the decimal no zero has any value. So you don't have to write 00832. No value is there. 832 multiplied by 10 raised to power minus 5, right? Ma'am, but in the question it is never given like this. They always, most of the options you will see, the answers are given up to 1 decimal. After 1 digit, you will see the decimal, right? Mostly answers are given like that, okay? But don't worry, we'll do that, okay? Firstly, I have converted it into simpler unit, right? Now, this is in grams. I have to convert it into milligrams. Beta, can you tell me grams to milligrams is smaller value, multiplication or division? Everybody, multiplication or division? What I have to do here? Should I do multiplication? Should I do division? I have to, whenever something smaller, I have to SM. Smaller means multiplication, right? So here I will multiply. So I have to multiply this. Milli means 10 raised to power 3. So I have to multiply with 10 raised to power 3. So 832 multiplied by 10 raised to power minus 5 multiplied by 10 raised to power 3. This is your milligrams, and this is coming out to be 832 into 10 raised to power minus 2 milligrams. But you know, answer will not be given in this way. Answer will not be given in this way. They will give you answer, rarely, I don't know, maybe they will give answer this way also, but most of the answer they give in the form of 1 decimal, right? So simple, see this thing here. Those students who get confused here, see, if you put a point here, right, that means you are dividing it by 100. That's why it is putting a point here. And simple is beta if you multiply this by 100, if you divide this by 100, right, we know that this division 100 will be a decimal here, right? Two zeros means after two digits you will have the decimal, right? You can erase this. This is 10 raised power 2. This is 10 raised power minus 2. That will be cancelled and you will have 8.32 milligrams. Okay, right everybody? Okay students, clear to everybody? When 3 we round off. Yes, very good, very good. Round off also is another task only that I'll teach you like in some basic concepts of chemistry. 8.3. If this digit is smaller than 5, you will directly write 8.3 milligram. That they also can give you. This much precision you don't need in exams and MCQs. Till here they can confuse you. After this they won't. There will not be option like 8.32 and 8.3, right? Till here they can confuse you with the decimals. Sometimes some options it will be 8.32. Some options it will be 8.3.2, right? These kind of options they can give you, right? Okay, Hema, Jato, then you have Vignesh, yes, Vasuki, Chara, Chandra. Okay, let's do this. Let's convert this. This is your, convert this into scientific notation. So scientific notation, beta, simple. After decimal, every zero has a value, right? So that means this is 1, 2, 3, 4, 5, 6, 7. This is 8901 multiplied by 10 raised power minus 7. Wait a minute. If you write it this way, it will be considered as 0.000891. It will be considered like this. So we can't write it like this, okay? We can't write it like this, right? Because that will be considered as something else only. So you have to write it as 8901,000, right? Multiplied by 10 raised power minus 7, right? If you keep it here, right? Because this is nothing but this is 0.8901 only, right? This you can also write it as, okay, this you have to understand. This is just given to confuse you. You can ignore these three also. You can write simply. This we will study in significant figures in some basic concepts of chemistry. In detail, we will study about which zero has value, which zero does not have value. Right? Now, if you have 0, 0, 0 here, they don't have any value. This will be 0.8901. You can just directly write 8901 multiplied by 10 raised to power minus 4. Right? Or if you're considering these zeros, then you also have to consider 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 0, 0, 0, 10 raised to power minus this. And this, if you convert this, this will be converted to into, if you multiply this 0, 0, 0, and this will be 10 raised to power minus 4, this will be 10 raised to power 3, this will cancel and you will get the same answer here. Understood? Yes, everybody? Okay. Chal. Now let's do this. Convert the following into scientific notation. It is already given in scientific notation. So you don't need to convert it into any scientific notation. But you can tell me one thing. If I have to convert this into, let's say, I want to convert this into Armstrong. Armstrong we have not discussed, no? We have not discussed about Armstrong, right? So let's convert this into Armstrong. Let's see who is going to convert this into Armstrong. Now guys, Armstrong is 10 raised to power 10 and it is a smaller unit than meter. Okay, so that means if this is given in meter, so meter to Armstrong is smaller. That means you have to multiply this or divide this. Multiply or divide, guys. Multiply or divide. You have to multiply this, right? So that means it will be multiplied by 10 raised to power 10. So answer will be 3.20 multiplied by 10 raised to power 30 multiplied by 10 here. That is the answer in Armstrong. And here the answer will be 3.2 into 10 raised to power 40 Armstrong. Right? Okay, everyone? Shall we move ahead? Shall we move ahead? Right, I know still you are confused about, ma'am, why you ignore this zero, all these things. Don't worry, some basic concepts of chemistry. I'll take up a dedicated lecture on significant figures. Okay? Yes, students? Okay, let's move ahead. Let's talk about, write the answer in the scientific notation if this thing is given to you. So whenever some addition, you get calculations like these, okay, and you want to have, let's say, answer for this, right? What you can do, convert this also, or this, convert this into 10 raised per 5, or convert this into 10 raised per 3. That means in addition or subtraction, power of 10 must be equal, right? So what I have to do here is 48.9 into what I can do, 10 raised per 3 plus, if I want to convert this, if I want to convert it into 10 raised per 3, right, then I have to multiply it by 10 raised per 2, divide it by 10 raised per 2, right? So when I divide it by 10 raised per 2, it will become 10 raised per 3. And this will be 200 or what, right? 200 multiplied by 10 raised per 3. Okay. So after this, what you will get? After this, what you will get? After this, students, what you will get? You have 10 raised per 3 as common, 48.9 plus 200, and by this you can easily solve your answer. Right? Okay, everybody, simple. This is just to tell you that whenever there is some addition or subtraction, you have to make the 10 raised to power that power as same. Right? Okay, now here you have subtraction. This is 10 raised per minus 6. This also, either you make this as 10 raised per minus 6 or you make this as 10 raised per 0. Right? Both the cases are same only. What I would like to do, I will make this as 10 raised per 0. So it will be 7.8900 minus, if I want to make this as 10 raised per 0, so I have to multiply by 10 raised per 6, divide by 10 raised per 6. This will be cancelled and this will be converted to 0.000123456412. Now you will say, ma'am, here you have after point 1, 2, 3, 4, 5, 6, 7. 1 point was already there. 1 point was already there here. I have jumped it to 6 digits. 1, 2, 3, 4, 5 and 6. That's how I got my decimal there. Okay. Now what you have to do is just subtract this and you will get your answer. Okay, everybody? Yes. Okay. What's your batch name? Beta, our batch name is Sigma batch, where we are teaching, right? And right now the classes are going on in the batch, right? And students are totally loving it. Okay. So let's see the next one. This is the division. Division is simple here. Division is simple. Division is 2.34 you have, 39.2 you have, multiplied by 10 raised per minus 5. And this is 10 raised per minus 12. So whenever you have this, it will come to numerator. So this will be, now whenever you are dividing, the decimal point should be same. If it is 2.3, this also should be 3.9. So what I'll do for this thing, I'll have to divide it by 10 if I want to have decimal point here. If I want to have decimal point here, I'll divide it by 10. Okay. And I'll also multiply this by 10. So can I say that? Okay, I'll tell you this again. Okay. You have this thing, I need to have decimal point here. If I multiply and divide this by 10, because of this 10 here, it will become 3 point, right? So it will become 3.92. We can erase this 10 here. This 10 is already in the multiplication. So you can see this. This will be 2. This decimal and decimal now will cancel out. 234 divided by 392 multiplied by 10 raised per minus 5 plus 12 minus 1. And that's how you will get your answer. 234 by 392 is complete calculation. You can do it yourself, right? Now this will be 12 minus 6 is 6, and that's how you will get your answer here, right? Okay, everybody. That is the benefit of converting. Ma'am, are you not allowed to speak in English? In Hindi? It's not about allowance, it's about the channel is for English audience, right? The channel is for those audience, those kind of students who study in their regional languages, or who don't know Hindi, right? They find it very difficult to get good content in English, like the language that they know, right? So that's why this channel was created, right? So that we can go to multiple state students, right? So that they can, like, not because they don't know Hindi, that's why they are not getting the level of content that they should, right? So that's why this channel was created, right? Okay. Now let's talk about next thing, that is pressure units, right? Pressure units. So now students, pressure units are three: atmospheric, Pascal and bar. Now if someone asks you what are the SI units of pressure, that is Pascal. Okay. So now this conversion also you will see, especially in thermodynamics, you will see this conversion a lot, right? That they will give you in atmospheric, you have to convert it into bar or into Pascal. For this, conversions are very important, right? So let's see that here. If you see, 1 atmospheric is a bigger unit as compared to 1 bar, right? So let's talk about, if you talk about 1 atmospheric to Pascal, wait a minute, right? If you talk about 1 atmospheric to Pascal, you have to multiply that by 101 in 101,325. Okay, 101,325 you have to multiply, then you will get the result in Pascal, right? Let's say they have given you 3 atmospheric. Okay, you have to convert it into Pascal. So this will be 3 into 101,325 Pascal. Okay, that's how you will get your answer in Pascal. Okay. Now, if it is given in bars and you have to convert it into Pascal, because Pascal is the SI unit, right? So now, if 1 bar is given, multiply this by 100,000, that means 10 raised to power 5, right? Multiply it by 10 raised to power 5 and you will get your answer in Pascal from bar. Kilowatt, can you convert Pascal to kilopascal? Easily you can convert it by multiplying with 10 raised to power minus 3. Can you convert Pascal to kilopascal? Easily you can do this. Multiply by 10 raised to power minus 3, multiply by 10 raised to power minus 3. Why? Because smaller value to bigger value will always divide. Divided by 10 raised to power 3, that will be multiplied by 10 raised to power minus 3. Okay. So these through this particular formula, not formula, the conversion, and this conversion is very important for your physical chemistry numericals, right? Now let's talk about a simple thing here. That is the base thing. That is, if you talk about the SI unit, 1 Pascal is equals to Newton per meter square. Because what is pressure? Do you know the formula of pressure is equals to force by area? This you have done in physics as well. Pressure is force. Force unit is Newton, right? Area unit is meter square. So that's why 1 Pascal is 1 Newton per meter square, right? That is the value. That is the value of 1 Pascal, right? And in CGS units, because force is expressed in dynes in CGS units, so it will be dyne. Area, the length is expressed in centimeter in CGS units, so it will be dyne per centimeter square, right? Now, if you want to convert 1 atmospheric to other things also, that is, this is very important, because this mostly you will see this thing, right? And this thing. You will see that in the exam. It's very normal, right? You will see pressure in solution chapter also in class 12th, in class 11th, you will see this, right? So 1 atmospheric is equals to 760 torr. That is also unit of pressure. 1 atmospheric is equals to 360 mm of Hg, mercury of Hg, right? Mercury, I'm saying mm of Hg, right? So here, Then 1 atmospheric, when you convert it in centimeter, you just have to divide it. So it will be 76 centimeter Hg, right? This though very rarely, this and this you will use, right? But you have to go through everything, but this and this you will use so much, and this also you will use, and this also you will use in your entire physical chemistry, right? Now let's do this volume units. Volume unit is also very confusing for students, because see, if it is given in liters or milliliters, then it becomes easy. But if it is given in decimeter cube, if it is given in centimeter cube, then it becomes very confusing for the students. Okay, so let's see this here. Guys, if you see liter, you will see usually in liters and milliliter. But what, ma'am, what is the SI unit? SI unit is meter cube, right? So firstly, let us see, if you want to convert meter cube to the liter, what will be the answer? So 1 meter cube is equals to, okay, first one more thing here. Milliliter is nothing but centimeter cube. Liter is nothing but decimeter cube. Okay, that you should know. Milliliter is centimeter cube. Liter is decimeter cube. And this is your SI unit, that is meter cube, right? Because what is volume? Volume is length into breadth into height. So it will be length cube, right? So length, if it is in meters, if it is in decimeter, if it is in centimeters, right? Mostly you will see the units in liters or milliliters. That's why this becomes very confusing for the students, right? So guys, if to make it confusing for you, they have given the volume like this, 1 meter cube. You can't just, this I have seen that students usually put meter cube as 1 liter. No, that's wrong. 1 meter cube is equals to 10 raised to power 3 liter, or liter is also called decimeter cube, right? 10 raised to power 3. Okay. Okay. So that means if I have to convert 1 meter cube to 1 decimeter cube, I'll have to, this is 10 raised to power 3. I'll have to multiply this with 10 raised to power 3. Right? Now, important thing here, right? If you talk about 1 milliliter, milliliter is also centimeter cube, right? Centimeter cube is also expressed as cc. Okay, it is also expressed as cc. You can write it here as well. It is also expressed in cc. Centimeter cube, cc. Sometimes they will give you the volume is this. You will see in the question. Sometimes they will give you 30 cc. Now students don't know what is cc, right? Cc is nothing but millimeter only. If they give you 30 centimeter cube, this is nothing but milliliter only, right? Now tell me one thing, if in the question they have given you something like this, you have 50 millicube. The answer that they have given, that is in, let's say, milliliter. What you will do here? Answer is given in milliliter, this is given in meter cube. So firstly you will convert it into liter, right? So you'll multiply this by 10 raised to power 3, right? So it will become 5 into 10 raised to power 4 liter, right? Liter to milliliter conversion is very simple. First you tell me here whether meter cube is greater or liter is greater. See, you are multiplying it with 10 raised to. Whenever you multiply, it is a smaller value, right? It is a smaller value that you are getting converted into, right? So you're converting it into liter by multiplying. That means you're converting it into a smaller value, right? So first you have milliliter, then you have liter, then you have meter cube. This is the value, right? So now when you are converting, this is also multiplied by 3, this is also 3. That means this is also multiplied or divided by 10 raised to power 3. This is also multiplied or divided by 10 raised to power 3. Now, let's say they give you some random value I'm picking. They give you 512, or let's say 80 millimeter cube they have given you. Meter cube, when it is converted to liter, it will be multiplied by 10 raised to power 3, right? Now liter, when it is converted to milliliter, it will again be multiplied by, because you're converting into a smaller value, milliliter, right? Again, it is multiplied into 10 raised power 3, right? This will be a milliliter. So answer will be 80, or you can say 8 into 336, 10 raised power 7 milliliter. Okay. Yes, everybody. Ma'am, please interact with the chat. You tell me what should I tell, what should I like interact, right? 2025 students, the exam is so towards the end of the 12th. Thank you, the crazy, for disappointing the students and demotivating them. Is this your work or what? Yes. So that is clear to everybody now. Volume, units, conversion, that is clear. Shall we move ahead? Right? Okay. Now that is this also we have done. Let's see this. An average human has 5.2 liter blood, volume of blood in meter cube. Liter to meter cube you are going. Smaller to bigger value. That means you are going to divide it, right? So whenever you are dividing something, right? Because this is 3, right? So that means it will be 5.2 into 10 raised power minus 3 meter cube, right? So answer will be 5.2 into 10 raised power 3 meter cube. So answer will be B is the correct answer here. Okay, everybody? Okay. Let's move to the next one, that is energy units. Energy units, everyone. After this is the last unit conversion that we are doing. After that, we are going to see the constants only, right? So energy units, if you see this here, energy units are, you have 1 joule, right? What is 1 joule? Energy is equals to force into displacement. Do you remember energy is equals to force into displacement? That is the formula that you must have learnt in your earlier classes, 9th or 10th class, right? So force is Newton, distances or displacement is meter. So it will be 1 joule is equals to 1 Newton meter, right? And what is 1 calorie? That is the SI unit. This joule is the SI unit. Okay, this joule is representing the SI unit of the energy. Now, this conversion of energy, you will see most of the chapters, thermodynamics, equilibrium, electrochemistry, chemical kinetics, solution chapter, it's not that much. Yes, in all these chapters of physical chemistry, you will see these conversions, especially in thermodynamics, you will see, especially in electrochemistry, you will see this, right? So wherever you will see energy, these conversions are important for you. Even in structure of atom, these conversion becomes very important, right? So here, if you talk about 1 calorie, that is equals to how many joules? 4.184 joules. Kilocalories is equals to 4184 joules. This conversion is not that useful, right? But still I have written it here, right? The conversion that is like mostly uses this thing. That is electron volt to joule, joule to electron volt. Okay. So if they have given you in joules, they have given you have to convert it into electron volt. You have to multiply with, this will be, wait a minute, let me just correct it here. This will be 10 raised power 18, right? This is the inverse of 6.02 into 10 raised power minus 90. Okay. If you see this here, this will be 10 raised power minus 90. Okay. This will be 10 raised power minus 90, right? So one is 1 electron volt is equals to 1.6 into 10 raised power minus 19 joule. If they have given you in joules and they are asking you to convert it into electron volt, ma'am, I don't want to remember this. Okay, it's totally your choice, right? If you want to convert 1 joule to electron volt, you can divide it by 1.6 into 10 raised power minus 19, which is nothing but this value. So directly I have given you this value. You can just remember 6.2 into 10 raised power 18, so that calculation becomes easy for you in the exam, right? You will say, ma'am, I to always divide it by 1.6 into 10 raised power minus 19. You can do that, right? But in that way, if you think that there are so many cancellation occurring in the calculations, then do this, right? If you think the calculations are, it's totally your choice in the exam what is happening. If the calculations are becoming easy by putting this value, do that. If the calculations are becoming easy by putting this value, do that. Totally your choice, right? Okay. Now, if you see this here, 1 electron volt, let's say this is so very rarely you will use this, right? Mostly this form, this unit conversion we teach so that you can divide it. Mostly you will see in the question it will be in joules or kilojoules. You will have to convert this into electron volt, right? So if things are given in kilojoules, first you will have to convert it into joules, then into electron volt. This is maximum questions you will see this only, right? Okay, but in some question it is also given that they have given in electron volt and they are asking you in joules. Mostly they ask either in kilojoules or in electron volt. Joules so very rarely you will see, right? But joules to kilojoule conversion is not a big deal, right? Okay, now let's talk about this gas constant, that is R. Now you have two constants with capital R. One is gas constant, other is Rydberg constant, that is represented by R or RH, right? Let's talk about these two things here. So if you talk about gas constant, right, this is the most confusing thing that I have seen students doing mistakes. Ma'am, gas constant have different values, right? So now the problem is, now when to put this value, when to put this value, when to put this value, right? See, if your, I'll give you a simple thing here, right? If you are using pressure or volume in the question, right? When those students who are from like who are already droppers or repeaters, they will get to know this more clearly. Like in solution chapters, you have volume, you have concentrations, you have pressure in atmospheric. There we use the value as 0.0821 liter atmospheric per Kelvin per mole, right? So for those students who are just they have just stepped out of class 10, for them pressure, if it is in atmospheric, and volumes, the differentiating factor is volume. If you're talking about volume, all of these things in the question, the R will be 0.0821, right? When you do the practice, that will be in your head only, that okay, this kind of question, some question R value is this, in some question, in some chapters R value is this, in some chapters R value is this. So when you will get to know about physical chemistry, you will get to know about this more in detail, right? But when I teach you that, remember this in mind, that pressure in atmospheric, volume in liter is going to be 0.0821. If pressure is in Pascal or you have energy, this you will use in thermodynamics. In thermodynamics, you are doing the question where energy is involved. You will use the value of R as 8.314 joule per Kelvin per mole. Can you see the difference? Here it is liter atmospheric, here it is joule. That's why whenever you use energy, you will use this value. Whenever you use volume, you will use this value. Whenever in the question energy is given in calories, then you will use this value, or approximately we use it as 2 calorie per Kelvin per mole. Now, an easy thing for all of you, yes. Instead of using this value, you can also use 1 by 12 here, because it will make this question very easy, because in fractions, you can easily solve the question, right? Less time consuming it will be. In this, you can use 25 by 3 as well. You can bring out the calculator, you divide this 1 by 12, it will be approximately this value. 25 by 3 will be approximately this value. So that also you can use. Okay, everybody? Right? Okay. Balancing, don't worry, I'll teach you that. Okay, I'll teach you balancing. Right? Now let's talk about Rydberg constant. This you will study in one Rydberg equation. See, this gas constant will be applied throughout the chemistry. Physical chemistry, you will see like most of the formulas, gas constant will be there. But Rydberg constant will be there only in Rydberg equation, right? So now in Rydberg equation, right, that I'll teach you in structure of atom. For now, just remember that you have two values. One is the value of RH, one is the value of 1 by RH. Right? Now, this I'll teach you in the equation, that why you have to remember the value of 1 by RH also. Right? That I'll teach you in the equation, that why you have to remember both the values. Right? To make the calculation easy, you should know both the values. This is 10977 per centimeter. Remember the units. Okay. Remember the units. This is per centimeter. This is 912 Armstrong. So I am not able to control it. So I'll just tell you here. This is basically 1 by lambda is equals to RZ square, 1 by N1 square by N2 square. This is the Rydberg equation. Ignore this, everything. Just remember this thing, that in this equation, lambda is inversely proportional to Rydberg. Can you see that? Rest of the things we will study. Now, if they ask you the value of lambda, that is wavelength, that we will study. If they ask you the value of lambda, this value, you will put the value of 1 by r, because that will make the calculation easy for you. Right? Because the formula is 1 by lambda is equals to RH Z square 1 by N1 by 1 by N2 square. So if you know the value of 1 by R1, you can easily, 1 by RH, you can easily solve the value of lambda with less calculation. But in this case, lambda will be in Armstrong. If in the options they ask you the value of lambda in nanometer, you have to convert this. In picometer, you have to convert this. Okay. And if you talk about the value 1 by lambda, if they ask you the value of not lambda, if they ask you the value of 1 by lambda, if those students who know, this is wave number, this is another thing that we will study in structure of atom. This is directly proportional. So for this value, you can directly put the value of RH. But remember, then wave number will be in per centimeter, not in meter. If you want to calculate this in per meter, then you will have to convert this into per meter. Right? I hope so. This thing is clear, that why we have to use the full value here. Right? Those who are not able to understand this, don't worry. Wait for structure of atom Rydberg equation. I'll solve all of this. Till then, just remember these two values, RH in centimeter and 1 by RH in Armstrong. Right? Okay, everybody. Now, last 2 pages of today's lecture, that is speed of light value, you should know, 3 into 10 raised per 8. Gravitational constant is 9.8 into 9.8 meter per second square, right? Then you can also take it as 10. 1 AMU, that we will study this. We are going to study all these values in structure of atom, right? This you should remember. Mass of electron, mass of proton, mass of neutron, 1 atomic mass unit, that we will study in some basic concepts of chemistry. Rydberg constant, I just told you, right? This value I told you this value in centimeter. Here it is written in per meter. Here it is written in joules. But what is the most important value? That is in here. Right? Joules, you don't have to remember this. Okay, you can skip that as well. Right? You can ignore that. Just remember in per meter or per centimeter. Right? Then students, you have Bohr radius, that also will study in structure of atom. Charge of electron, structure of atom. Avogadro's number, we will study again in mole concept. Boltzmann constant, that we will study in, mostly this is studied in states of matter in JEE advanced lectures, okay. Then Planck's constant, this is an important constant that you will study throughout chemistry. The value is 6.6 into 10 raised per minus 34 joule second, right. Faraday constant, that also you will study in electrochemistry, that is approximately 96500, right. So that is very, very important, some important physical constants of chemistry that I have written here. Okay, students, right? Ma'am, too complex to remember. Arey, these will be on your tips, right? You don't have to remember this right now. Okay? You don't have to remember this right now. As we proceed with the chapters, that will be on your tips only, because we are going to use this Planck's constant. We will use every other numerical. Faraday is 96500, very simple, right? This, I would advise you right now, you can ignore this. Avogadro's number to we have studied in class 9th also. Charge on electron, mass of electron, charge of proton, neutron, mass of proton, neutron, that all we will study in the, but that you have to remember, right? That we will study in structure of atom, but you should remember. Bohr radius also we will study in detail, right? So all of this is just a like overview of what we are going to study in physical chemistry. What are the values that should be on your tips, right, before going to the exam, right, before going to any mock test, right? These value of physical chemistry should be on your tips if you want to get good marks in physical chemistry, right? Okay, students. So that's it for today. Now that's it. Now I have a question for you. This is the first question, that is SI unit of intensity. First question, take the screenshot. I want you guys to comment it down in the comment section, right? Everybody comment it down in the comment section. From the next lecture that I'm going to take up on Saturday, organic chemistry, I'll give like how many students have answered the question correctly or not, right? I'll see that. Okay. And also the students who have answered on the previous video, I'll also take up the basics, foundations of chemistry. I'll see how many of you have answered. I have given you one question of organic chemistry in the basic foundation. I'll pick out both the screenshots, that how many students have answered that basic questions in the foundation lecture and in today's lecture. This is the first homework. This is the second homework. The SI unit of volume is what, right? Okay. Yes, everybody, the SI unit of volume is what? This is also your homework question number 2. This is your question number 1. And I want you guys to comment it down in the comment section regarding your homework. And this is our Telegram channel. You can go and scan this and subscribe to the Telegram channel, because there you get all the live sessions, right? All the reports are there on the Telegram channel. Also the quizzes, everything is there on the Telegram channel, right? We don't want you to miss any lecture, right? Okay. And if you want to see Diksha ma'am happy, what you have to do is like this video, share this video, subscribe to the channel, and also click on that bell icon so that you can also, when I am taking that upcoming lectures, right, you can get notified for that. Otherwise you'll miss the lectures and you'll end up wasting time, right? Okay. So instead of that, do like, share and subscribe, and do your homework, because I'll be waiting for your homework in the comment section, right? And for the students who are looking for the offline centers, then students, you can see our results of JEE Advanced, right? The shining stars here. And for that, we are providing you IB SAT scholarship program, right? Which is Vedantu Instant Scholarship Program. Up to 90% scholarship you can avail here. And we are also giving you rank improvement, guaranteed rank improvement, or 100% fees refund. You can see the center JP Nagar, Bengaluru here. You can call on this number. You can visit the teachers, the counselors. You can talk to them right on the center. Or if you're not from Bengaluru, then students, don't worry. Here we have other states also, Tamil Nadu, Andhra Pradesh, then you have Telangana, Punjab, Maharashtra, Delhi, then Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, Uttar Pradesh, right? So wherever you are, our Vedantu center is near you. Go and visit the center so that you can get to know about more about this scholarship, and you can register yourself. That you can register online also, but I would advise you to give the test offline, right? Okay. Yes. Okay, so the class is over, guys, and I'm waiting for your comments in the comment section. Bye bye. Diagram in NCERT analytical balance. Ma'am, is it important to learn? You have to send me that. I have no idea what you're talking about, right? Okay, Taruna, Rohit, Malish, Hodin, GV Creation, Sidesh. Thank you, yaar. Okay. Okay then, beta. Bye bye. Take care. See you all in the next class. Bye bye.